Okay, guys, so let's talk thermodynamics. This is included. This is Unit 6. Unit, I think it's 8 or 9. 9 is not included. You'll notice you don't see on here entropy. So there's some concern that entropy may sneak its way in, or that a lot of this can't really be tested. I think that these things are definitely fair game. So don't let anyone mislead you. So, you should know if something is an endo or exothermic process. That means whether the products or the reactants are higher in energy will tell you whether it's endo or exothermic. Energy diagrams, you should be able to understand or plot what an energy diagram would be for a particular process. You would start always on the left with your reactants. Your right side of your graph should be your products. If it is exothermic, then it should have a lower energy for products and a higher energy for reactants. And endothermic would be a higher energy for products and a lower energy for reactants. And you should be able to subtract the products minus the reactants to find the energy change. If that number is positive, it's endothermic for delta H. If it is negative, it is exothermic. Heat transfer and thermal equilibrium. This is where we get into calorimetry. If you have a coffee cup calorimetry, the hot body will always lose energy in the form of heat to the colder body. And you should be able to calculate the equilibrium temperature for both things. Heat capacity and calorimetry continue kind of the same idea. You should be able to do calorimetry calculations. You should be able to design and set it up. You should be able to tell what measurements are taken. And whenever they ask for a measurement, they are not asking for something that you would have to know, but more reading something like mass, reading temperature initial, temperature final. You cannot record as a measurement a change in temperature. To record a change in temperature, you would have to have an initial and a final temperature. But you would record the mass. You would not consider heat capacity a measurement. It is a value you have to know. So be clear on for yourself whether or not it is a measurement or if it is just a constant that you need to know, and make sure you answer the question that they are asking you. Phase changes and energy of phase changes. There are two parts of this graph. There are the parts that the slope is equal to 0, and then there are the parts that have a positive slope for this heating curve. If we were talking a cooling curve, there would be parts with a slope equal to 0 and a negative slope. So in the areas where there's a positive slope, this is where we have change in temperature, and we would have Q equal C sub P times mass times change in temperature. When we have a flat part of this graph, we know that the energy is going in to change the bonds in between the molecules, and it is not allowed or able to change the temperature for that object. So you have two different calculations, one for the flat parts and one for the sloped parts. And the flat parts, you should use that delta H equals the either heat of fusion or heat of vaporization times the moles. So you would have to have the mass converted into moles. For the sloped regions, you would have Q equals M times C sub P times delta T. And you should know whether something is endo or exothermic. And I always recommend that you think about when you sweat, the reason you sweat is to cool your body. And so you can figure that the evaporation for your body is giving your body is giving heat to the water to evaporate. And so that should allow you to determine whether it's endo or exothermic. Enthalpy of reactions, we have several ways to calculate these, and you should be familiar with each so that you can calculate them. You could be given calorimetry data to calculate delta H. You could be given bond enthalpies to calculate H. You could be given enthalpies of various things and ask you to apply Hess's law. So, bond enthalpies. You would be given data, something like this, and you may be asked to calculate the enthalpy for this energy of this reaction, or you could have the energy for this reaction and be asked to determine the bond enthalpy for some particular part. You have to remember that you're going to take the bonds broken minus the bonds formed, and you are going to have to multiply by any coefficients, and you have to know whether you have a single or a double bond or a triple bond in some cases, so you have to use the right bond type as well. I strongly urge you on these questions to write out the Lewis structure so that you know whether it's a single or double bond, so that you can select the correct values. Enthalpy of formation is always writing the energy of forming a substance for 1 mole of it from its elements, all in their standard states, and that means at 25 Celsius. So oxygen would be a gas, water would be a liquid, and you have to select the right values. Typically, they will give you the right values, but it's something to be concerned with. Hess's law, I've talked about this briefly. It's again that same equation that you saw back here where it's the reaction is products minus reactants, and so that's just a form of Hess's law. So I have one last unit to cover, and I will get to that later today. Thank you.